The objectives of this module are to define embodiment design and introduce several graphic tools that enable embodiment design, provide examples of functional layout diagrams, provide examples of high-level architecture diagrams, and encourage you to delay working in CAD until you have a clear picture of the design approach you intend to pursue. As we've discussed in class, there is no one design process. However, if you zoom way out, most design processes have some things in common. The idea that you start with user needs, define form prior to function, and then move into the detailed design and implementation are common. Embodiment design is simply the process of taking rough ideas about the intended functions of a product and converting them into a workable design solution. It's about the fuzzy transition from data collection and brainstorming into detailed design. And a common mistake engineers make is to try to complete embodiment design in CAD. There are better, more efficient, and faster ways to move through this transition, and bonus, when done right, they tend to help us develop more creative solutions. So let's look at an example. Say we've been hired to design an electric toothbrush. The first thing we'll want to do is get a feel for user needs and the competition. We might do a detailed competitor analysis and benchmark features and capabilities. Then we might do some user testing with existing products to identify pain points. We might even capture all this information in a house of quality to develop our requirements. Next, we sit down and map out the required functions of the toothbrush and decide on targeted behavior of the toothbrush system in partnership with the client. We've probably already started looking at some super high-level concepts at this point, too, because it's hard to resist. So we might have a general direction we're thinking of proceeding. But now what? Well, now we're entering into embodiment design. I don't worry too much about items 1, 4, and 5 on the list shown. Items 4 and 5 determine the form or shape of parts that will satisfy the required functions. The engineering drawings of the product are what many people enjoy and think of when using the word design. But if we skip steps 2 and 3, developing the product architecture and refining our design parameters, then we often end up shooting ourselves in the foot and prolonging the design process. So let's look at these items in more depth. Let's look at a textbook example of embodiment design. Literally, this came from a textbook. This is the functional diagram for a proposed electric screwdriver. You can take your functional definition of the product, which hopefully you've captured and which is covered in another module, and start exploring how hardware could be assigned to accomplish the different functions. So, store electricity becomes a debate about types of batteries to be used, and looking at the couple solid function leads to a comparison of different alternative chuck systems. You use this extremely basic diagram for your system to drive discussion of design options precisely because it is vague on details, and will hopefully help your team think creatively about possible solutions that might not come up if you dove into CAD and pulled some random battery down from your typical website of choice. Mine's McMaster-Carr. And notice there are multiple ways you could group functions together. If we combine all the functions in the top row of this functional tree into one part, we end up with a robotic tool changer, right? If we find a separate physical solution for each box, that looks different too. So this can be useful, especially for circuit board and software development in embedded systems. And we can go a step further and begin overlaying our concepts with functions to help explain them and communicate them more clearly to other people. Once we've made sure all our functions are captured within a functional layout diagram like that shown, we can go a step further and begin to sketching the actual physical architecture of the system. With that rough sketch in hand, we can now work efficiently in CAD to detail the design. Again, the purpose here is to accelerate the design process by using quick, simple graphics before diving too far into the details. The more you can communicate your concepts and ideas early, and at a high level with both your team and client, the less chance for miscommunication or crossed wires within the team. But let's go back to the toothbrush example. We had a customer need that safety was paramount, but we also need to charge the toothbrush from a standard wall outlet. Let's say you're in charge of designing the electronics in the toothbrush. You could combine the charging and store energy functions in the handle, or you can split those functions. The same goes for power conversion from AC to DC. Where should those functions live? By drawing high-level functional or architectural diagrams, you can debate these issues and highlight the pros and cons before you fully commit to a path forward. In this case, due to user safety, it was decided to pull all power conversion and charging logic into the charger base, so that nothing that the user would hold had more than 5 volts running through it. Other options were considered, but quickly, using these diagrams and a little supporting research, rejected. Then as the designer, you can begin labeling this simple diagram with target requirements and specs. As you can see here, applicable standards and physical details, like that a USB cable would be used, have been annotated by the designer. With this approach, you are tackling the design from the top down. Something as simple as this rough architectural diagram of the toothbrush side electronics helps allow the team to begin labeling voltages and delegating the selection and testing of batteries, motors, and the like. You're peeling away the design one layer at a time. With the top-level architecture agreed upon, now you start figuring out the circuit design, defining the overall architecture first. Finally, you get to board layout. If you skip straight to board layout, you'll waste tons of time and miss things that should be obvious. Luckily, this process only applies to electrical engineering, right? Wrong. This holds true for every discipline. So in summary, embodiment design is taking needed functions to detailed design. It involves capturing and communicating your ideas early and understanding the big picture before you dive into CAD. Use simple box and line diagrams to your advantage to move your design forward faster and better. Now let's check your understanding.